Raising the height of the San Vicente Dam set a global record as a bold, massive feat of engineering. The tallest concrete dam raise in the United States stands near San Diego, California. It is also the tallest dam extension built using roller compacted concrete, or RCC, in the world. More importantly, the project secured a safe, reliable supply of drinking water for the 3.1 million people living in the 3,600 square kilometer region. For decades, the San Diego County Water Authority kept the water flowing by importing up to 80% of the water supply from Northern California and the Colorado River, both more than 600 kilometers away. But the region was at high risk of being cut off from life-sustaining water if a natural disaster, such as a major earthquake or drought, interrupted imported water supplies. To reduce the risk, the height of the San Vicente Dam was extended by 35.7 meters, the equivalent of adding a 12-story building on top of the original dam. The expansion took 6 years to complete. It more than doubled the capacity of the reservoir, creating an emergency water supply to serve the entire region for up to 6 months. It was 1943 when the original San Vicente Dam was first built. The structure was a conventional concrete gravity dam founded on bedrock and topping out at 67 meters. Work to prepare the original dam and foundation for expansion began in 2009. Using many innovative technologies and construction methods. First, the original foundation was excavated and the surface of the dam prepared to create a proper bonding surface. 3 inches of concrete were removed from the downstream face through hydro-demolition. Using roller compacted concrete for the new build was a key design element. Unlike conventional wet concrete, which is poured, RCC uses less cement and water to create a cookie dough or clay-like texture. Equally as strong as wet concrete, RCC is placed in layers, one on top of the other, and compacted. This placement process resembles road construction. This state-of-the-art application method shortens construction time while meeting all technical requirements. A total of 468,000 cubic meters of RCC were used to raise the dam to a new height of 102.7 meters. The concrete mix was carefully designed and tested to match the strength of the original dam and ensure that the original and new sections of concrete would bond seamlessly. The joint of the original and new construction was strengthened at the interface using grout-enriched vibratable RCC, GEVR. This placement method simplified construction and helped eliminate the use of steel dowels other dam raise projects used previously. Not only is the new structure able to withstand a 7.5 magnitude earthquake, but it is built to remain in operation in case of such a seismic event. To further improve dam safety, a new low-level outlet system was installed to make the raised dam capable of fast releases to lower the reservoir quickly in an emergency. Importantly, the reservoir remained in operation during the years of site preparation and construction. A steel cofferdam was built and installed underwater to safeguard the mechanical and electrical equipment needed for ongoing dam management. Since its completion in 2014, the San Vicente Dam raise has performed without incident or safety issues, confirming that the design intent was met. Beyond robust design and innovative construction methods, expanding the San Vicente Reservoir had many advantages over building a new dam. Not only was the raise less expensive than constructing an entire new dam, but the project was done in a way to reduce environmental and social impacts. Nearly all the concrete for the project was produced on-site. Rocks from the hillsides around the reservoir rims were mined to produce aggregate. A mix plant and conveyor belt system were set up on the premises to carry the RCC to the work site. These measures reduced the project traffic by avoiding 100,000 delivery truck trips through the local community. Extensive and early public outreach ensured that the area residents and business owners were well informed about the project. Multiple community meetings and feedback opportunities also supplied valuable local comments that were incorporated into the design. For instance, at the request of the community, the downstream surface of the raised dam was darkened with a varnish stain. This minimized the reflection and brightness of the new structure and helped it blend into the surrounding desert geology. Other direct benefits for the local community were new recreational facilities, including an expanded marina, boat ramp, and launch dock. The public welcomed the new amenities, which were built with recycled construction materials that were ground into aggregate on site. From start to finish, there was significant public involvement in the open project planning process and successful cooperation with local water agencies and the City of San Diego. This led the United States Society on Dams to use the San Vicente dam raise as a model for other dam owners on how to plan, secure approvals, and community support to construct a dam in today's regulatory environment. Today, it is our great honor and privilege to accept this important recognition from the International Commission on Large Dams and the Chinese National Committee on Large Dams. We would also like to thank the project team at the San Diego County Water Authority, our colleagues at the City of San Diego, and the many contractors and consultants who provided the dedication and expertise necessary to complete this project safely and successfully.